All right, friends and neighbors, welcome back. We are in our review sessions, and this week we're reviewing chapters 21 through 29 with the Do I Know This Already questions. The focus of this section of the book is all about OSPF and IPv6, so that is the lion's share of the content. So make sure you dig in and practice that routing and practice your next generation addressing. By the way, I decided to leave in the introductory part for each chapter. Let me know if it's disorienting or if you prefer just the little arrows that says, hey, these questions are for this chapter. All right, friends and neighbors, welcome back to another networking video. Today we are covering chapter 21 of the CCNA certification course, Understanding OSPF Concepts. All right, did you know this already? Questions. Which of the following routing protocols uses link state logic? Well, by now we know that was OSPF, that was D. Which of the following routing protocols use a metric that is, by default, at least partially affected by link bandwidth? And that is both the hybrid or advanced distance vector and OSPF, so C and D. Which of the following interior routing protocols support variable length subnet mask? Well, that was everybody except RIP version 1. RIP version 1 was what we call class full, so everybody else now does variable length subnet masks. Question number 4. Two routers using OSPF v2 have become neighbors and have exchanged all LSAs. As a result, router 1 now lists some of its OSPF learned routes in its routing table. Which of the following best describes how router 1 uses those recently learned LSAs to choose which IP routes to add to its routing table? Remember that at this point, we have an updated link state database. And so now what we have to do is run the shortest path algorithm against the LSAs. Which of the following OSPF neighbor states is expected when the exchange of the topology information is complete between two OSPF neighbors? Okay, when they first figure out that they can be neighbors, that is the two-way thing. Once they do that, we saw in the routers that they've exchanged link state database were now full. And our last question for this chapter, a company has a small medium-sized network with 15 routers and 40 subnets and uses OSPF v2. Which of the following is considered an advantage of using a single area design as opposed to a multi-area design? It's just simpler planning, makes life much easier. Now, from a performance perspective, right, the multiple areas might be able to calculate their link state databases quickly or more efficiently. They would still need those summary LSAs, but a single area autonomous system in this case just makes life much simpler. All right, friends and neighbors, it is time for CCNA Chapter 22, Implementing Basic OSPF Features. Before we dive in, if you like what we're doing on the channel, if we're helping you on your journey, give us a like and subscribe. It really helps us out. But now it's time for some OSPF features. All right, did you know this already? Question number 1, which of the following network commands following the command router OSPF1 enables OSPF on interfaces whose addresses are the following? So this is very similar to question number 2, except this value right here, we're looking at that second octet, right? And they look the same, but take a look at the answers. They reference the 10net instead of the 10.1. So we got to be really, really careful with that one. So answer to question 1 was 10.0.0.0, and then the wildcard mask was 0.255.255.255, which would capture all of these because it doesn't matter what went on in the last 3 octets. This is as opposed to the answers that were here that began with 10.1, and so we needed a different wildcard mask. Which of the following commands list the OSPF neighbors off interface serial 0? Well, there are 2 of them. You could just do a show IP OSPF neighbor, or you could just say show IP OSPF neighbor and then serial interface or serial 00. Both of those would work. Now, when you reload, and this was the router ID question, so you had to know for this question how you choose a router ID. So the question says that there's a couple of interfaces that are active, and some of them are are loopbacks. So the key here is that you're going to pick a high IP address, and you're going to prioritize loopbacks over physical interfaces. So in this case, the highest loopback was 10.8.8.8. The other ones were not loopbacks. Even though they were higher, they were not chosen. The other key here is that there was no router ID command. Router ID command overrides everything. Question number 5, an engineer migrates from the traditional configuration that uses the network command. So that was the first way that we did this. Instead, to use the OSPF interface commands. Which of the following commands configures the area assigned to an interface? Well, we just saw that when you go into an interface, you do IP OSPF, then the process, and then the area. The nice thing is you don't have to worry about the network ID in that case. So question number 6 is similar, right? We're going away from the OSPF network command, and we're going to do it per interface. Which one of the commands, which show command identifies whether an interface has been configured with the OSPF process ID? Well, if you go and you now do the show IP OSPF interface commands or show IP protocols, which will show the interfaces that are involved, those two will give you the details you need about the interfaces. There you go. All right, friends and neighbors, welcome back. Welcome back. Today we are tackling Chapter 23 in the CCNA, implementing optional OSPF features. Okay, the do you or do I know this already questions. Routers 1 and 2 with router IDs of 1.1.1.1 and 2.2.2.2 connect over an Ethernet WAN link. Use if all the default OSPF settings are used. If the WAN link initializes both routers at the same time, which of the following answers would be true? Well, we know that the default would be a broadcast network type, so they would still discover each other, and then we would use the higher router ID to become the designated router. So that was B and D. All right, same problem. The configuration uses all defaults except giving router 1 an interface priority of 11, so higher priority, and changing both routers to use the OSPF network type of point-to-point. Okay, the tricky thing here is that there's going to be no designated router, but we will still discover each other. Now, it doesn't change based on the priority. So the answer here was B and C. Router 1 will still learn about router 2 and vice versa. Router 2 will not be the designated router or the backup designated router because we're doing point-to-point networks. Question number 3, per the command output, how many routers is router 9 fully adjacent? Well, the key is right over here. So that we've got several neighbors that are out there, but only 2 are going to be full. So the answer was D, 2. Routers 1 and 2, which use default priority settings, so they're all going to be 1, become neighbors with R1 as the designated router and R2 as the backup designated router. An engineer then configures router 2's interface to use a priority of 100. Which answer correctly predicts any change in the OSPF neighbor relationship? Well, there would be no change, right? We saw that if you change the OSPF config, it doesn't just automatically change things around. But if the neighbor relationship failed, then the one with a higher priority would become the designated router. So that was B. Which of the following configuration settings on a router does not influence which IPv4 route a router chooses to add to its IPv4 routing table when using OSPF-V2? The only thing that we haven't talked at all about is the delay, so that was B. The network engineer configures the IP hello interval of 15 subcommand on the interface that connects the OSPF neighbors for router 1 and router 2. So that's a long hello interval. But with no use of the IP OSPF dead interval subcommand. Eventually, router 1's OSPF process fails, but the link between router 1 and router 2 remains working. How long after router 1's last hello does router 2 consider the neighbor relationship R1 to fail? Well, by calculation, that would be 4 times whatever that setting was. So it would be 60 seconds. Now, that's the chapter thing, right, that we saw that was a little different in Packet Tracer, but there we have it. All right, friends and neighbors, welcome back. We are doing CCNA Chapter 24, OSPF Neighbors and Route Selection. And it turns out that this is the video that we're going to use to close out the whole OSPF series. Now, if you've been watching through all of these, you're probably like, it's about time. But we're going to break some things today, so maybe that's a fun way to close things out. All right, did you know this already? An engineer connects routers R11 and R12 to the same Ethernet LAN and configures them both to use OSPF2. Which answers describe a combination of settings that would prevent the two routers from becoming OSPF neighbors? So remember, these are things that we just did that would break the neighbor relationship. If you have an error or a timer mismatch, instantaneously your neighbor relationship is going to have problems, as we saw this video and the previous one. All right, question number 2. An engineer connects routers R13 and R14 to the same Ethernet LAN and configures them to use OSPF. No surprise. Which answers describe a combination of settings that would prevent the two routers from becoming OSPF neighbors? Now, this was, trying to get after the same topic. Routers using the same router ID will have problems, right? That was the one that they kept trying to be neighbors, but they couldn't because they had the same router ID. Question number 3. Router R15 has been a working part of a network that uses OSPF v2. An engineer then issues the shutdown command in an OSPF configuration mode on R15. Which of the following occurs? Well, the answer to that one was D. The config is kept, but all OSPF activities cease. So everything is gone that you learned via OSPF, but the config lines are still there. So if you did a no shut, it'd be right back in business. Question number 4. Using OSPF, router 1 learns 3 routes to the subnet 10.1.1.0/24. The first calculates a route through router 2 with a metric of 15,000, and then a route through router 3 with a metric of 15,001, and then a route through router 4 with a metric of 15,000 again. Which routes does the router place into its routing table, assuming that all default configuration settings for any features that would impact the answer? Well, we now know the answer. We're going to do an equal cost multipath thing. So the metric is the same to that destination from 2 different routes. So we install both of the routes with the lower metric of 15,000. Question number 5. Router 2 runs both EIGRP and OSPF. So it's doing EIGRP out one way and OSPF out the other. It learns 2 OSPF routes to subnet 172.16.1.0/24, one with a metric of 1,000 and one with a metric of 2,000. It learns 2 EIGRP routes with metrics of 1,000,000 and 2,000,000, huge metrics. If using the default settings for any settings that might impact the answer, which routes will the router place in the routing table? And the answer here, even though the EIGRP routes have a huge metric, EIGRP has a lower admin distance when compared to OSPF. And so the EIGRP route with a metric of 1,000,000 would be installed. Question number 6. Router R3 receives a packet with a destination IP address of 172.20.89.100. How many of the address ranges defined in the routes per the show IP route command match the packet's destination address? All right. Well, we know right away that the default route is going to match, so that's 1. Now the destination is 89.100. If we look all the way at the bottom, 172.20/16, that covers that, so that's 2. 172.20.80.0/20, well, that's actually 80.0 to 95.255, so that covers it. That's 3. And then the next route up, the 172.20.88.0/23, that's actually 88.0 to 89.255, so that one covers it as well. The next one up does not. So the answer was there are 4 routes that actually match that destination, all with different masks. Now the question would be, which one would you take? It would be the one with the longest prefix length. But that's why looking at routing tables is sometimes a subnetting problem. Question number 7. Router 3 receives a packet with a destination address of 172.20.90.1. Which next hop IP address does router 3 use when forwarding the packet? And the answer was C, 172.20.13.3. Now that's this address down here. The bottom entry matches, but it's got a very short prefix length. So this one here has a better prefix length. The longer one gets it closer. It's more specific. This one here does not match because this is 88 and the 89 subnets, so it doesn't match. This one here is too specific, so it's not this IP address. So that's why it is the answer right here, 172.20.13.3. All right, friends and neighbors, welcome back to another CCNA networking video. We are working through Chapter 25, Fundamentals of IP version 6, or just IPv6. Okay, did you know this already? Which of the following was a short-term solution to the IPv4 address exhaustion problem? Well, we know the answer there. CIDR was one of them, but in this particular question, the answer was C, network address translation. Question number 2, a router receives an Ethernet frame that holds an IPv6 packet. The router then decides to route the packet out the Ethernet WAN link. Which statement is true about how a router forwards IPv6 packet? Well, we know that any router that gets an IPv4 packet destroys the Ethernet frame and then builds another one on the other side. The same thing happens here. So the answer was A. Question number 3, which of the following is the shortest valid abbreviation for FE80? By the way, that's a link local address. And then look at all these zeros. Look at all the quartets with zeros right here. But we got another one. Which can we suppress? Well, the longest one. We can only do it once, but we can do leading zero suppression. So that's where we get the answer D. Question number 4, which of the following is the shortest valid abbreviation for the following IPv6 address? Well, it's a little weird. We've got stuff in almost every quartet, but we've got a whole bunch of zeros that we can suppress. So that's why we get the answer B here. Here we couldn't use the double colon, right? Even though we got lots of zeros. And we can't do the following zero suppression, only the leading zero suppression. Which of the following is an unabbreviated version of an IPv6 address? So you got to take this address and figure out how to expand it now. We see the double colon. So if we filled in all of these with the leading zeros that we know had been suppressed, so there's a 0 here, and then 2 zeros there, and then we just fill in the rest with all zeros where the double colon is, that's our answer. Choice A. Question number 6, which of the following is the correct abbreviated subnet prefix for an address 2000, so on, this IPv6 address? Now this one's already expanded for you, and so all you have to do in this case, because it's a /64, it's an easy one. Where is the 64 bits that we need? Well, the prefix would be 2000, 00, and then 5. And then if we want to abbreviate this, we can do the zero suppression here. Now, why can't we do a double colon here? Well, the answer is that we're going to convert all of these to zeros. And that will be 4 quartets, and we can only do it once. So the correct abbreviation of the prefix is choice C. All right, friends and neighbors, welcome back. We are in Chapter 26 of the CCNA study guides. And in this chapter, we're tackling IPv6 addressing and subnetting. All right, time for the do you know this already questions. Which of the following IPv6 addresses appears to be a unique local unicast based on the first few hex digits? Well, now we know that unique local addresses begin with FD. And so that was the answer, Charlie there, or C. Which of the following IPv6 addresses appears to be a global unicast based on the first few hex digits? You're seeing a theme here, right? If you look at the first couple of hex digits, you know what class of address they're going to be, or what type of address. The same was true for IPv4. Class A, B, and C had a very particular range of addresses. In this particular case, the global unicast is A, beginning with 3123, right? Begins with a 2 or 3, that's global unicast. Question number 3, when subnetting an IPv6 address block, an engineer shows a diagram or a drawing that breaks the address structure into 3 pieces. Comparing this concept to a 3-part IPv4 address structure, which part of the IPv6 address structure is most like the IPv4 network part of the address? Well, the network was the prefix, and so in IPv6, the answer was D, the global routing prefix. Question number 4. When subnetting an IPv6 address block, an engineer shows a drawing that breaks the address structure into 3 pieces. Once again, assuming that all subnets use the same /64 prefix length, which of the following answers lists the field's name on the far right of the address? That's 64 bits of address space for host. That's called the interface ID. For the following IPv6 address, which part of the address is considered the global ID of the unique local? Well, that was why I had that in red in the earlier part of this presentation. So the part beginning after Foxtrot Delta, after FD, that is the global part of the prefix. So 00, 1, 2, 3, 4, 5, 6, 7, 8, right? So that 40-bit chunk is the global ID for the unique local address. Whew, that is a mouthful. All right, friends and neighbors, welcome back to another networking video. This is going to be chapter 27 on CCNA. This video is probably going to be one of the weirder ones that I've done, only because I'm recording this on Amtrak's the Southwest Chief. And so hopefully the audio is okay and the lighting's okay, but the audio is more important clearly. But here we go, chapter 27, implementing IPv6 addressing on router. Did you or did I know this already? Questions? Question number 1, router 1 has an interface, G01, with a MAC address. Which of the following commands added to the configuration would give the interface a unicast IPv6 address of, what do you see there? And the answer is just the first static configuration mode that we had, right? So you just specify IPv6 address and then what you want it to be, so standard format. Question number 2, router 1 has an interface named G01, whose MAC address has been set. The interface has been configured with an IPv6 address with the EUI argument, the EUI64 subcommand. What unicast address will the interface use? Well, this is your understanding of the conversion, right? So we just stick FFFE right in the middle, and then we flip that bit on the 7th bit. So it's 52, 55, 44, and so on. Router number 1 currently supports IPv4, routing packets in and out of its interfaces. Router 1's configuration must be migrated to support dual stack for both. Which of the following tasks must be performed before the router can support IPv6? Well, we know the answer to that one. We've got to turn on IPv6 unicast routing and then give the interfaces their IP addresses. Question number 4, on a router configured with an IPv6 address, which commands will show the prefix? Choose 2. Well, B and D show IPv6 interface brief or just showing the interface itself. And we saw that prefix length in the examples earlier. Question number 5, router 1 has an interface, G01, with a MAC address configured. The interface is then given an IPv6 address. If no other interface commands are used, which of the following will be the link local used on the interface? Well, again, the conversion, but in this case, it's got the MAC address configured, right? So you'd be putting it in there, flipping the bit, and then doing all the zero suppression. So that was A. Question number 6, which of the following multicast addresses is defined as the address for sending packets to only IPv6 routers on the local link? Well, we know that was the all routers multicast, so FF02::2. And the important thing there is the ::2 is the all routers, and the first two, FF02, that's the scope. Question number 7, host C must forward a packet to its default gateway. And there's our default gateway address. Host C does not yet have a neighbor table entry for that address. To which solicited node multicast will the host C send its NDP neighbor solicitation? Well, we know now that the solicited node multicast will have FF, right? It'll have this pattern here, FF02::1 FF, followed by that node's unique identifier. Now, question 8 is a little tricky. It has a whole bunch of IPv6 commands that all worked, and you have a couple of interfaces that we're dealing with here, 01, 02, 03. What happens after all this is done? The answers were B and C, that G001 would have a link local address, but no other addressing, and G002 would have the identical configuration. All right, friends and neighbors, welcome back to another networking video. We are doing chapter 28 of the CCNA, implementing IPv6 addressing on hosts. Now, I think what we're going to do in this video is, instead of doing a lot of packet tracer, I was looking at that. I'm not really satisfied with what that shows as far as the network discovery or the neighbor discovery protocol and the addressing. So I think we're going to do a lot of PCAPs today. Okay, do you know this already questions, or do I know this already? PC1 to PC2 and the router 1 are all connected to the same VLAN and IPv6 subnet. VLAN is important, right, because we put everybody in the same VLAN and therefore the same IP network. PC1 wants to send its first IPv6 packet to PC2. What protocol message will PC1 use to begin the process of discovering PC2's MAC address? Well, we know that this is the neighbor solicitation. Which of the following pieces of information does a router supply in an NDP router advertisement? Now, there are two of them. We're going to get the router's address and the prefix. So if you didn't learn the router, or you didn't learn the router as a neighbor, right, you're sure going to learn it as part of the router advertisement, router solicitation exchange, but importantly, the prefix. Did you know this already? Question number 3. 3 routers are connected to the same VLAN and IPv6 subnet. All 3 routers have responded to various NDP router solicitation messages with an NDP RA, or advertisement. Which answer best describes the kind of information held in the output of the show IPv6 neighbors command on R1? So we saw this earlier. We know that you're going to have your IPv6 addresses and your MAC addresses, but there'll be no indication that, hey, I'm a router. We just learn that they are in fact routers from those messages. PC1 and router 1 connect to the same VLAN. The user pings the IPv6 address of a host that sits on a remote site. So across the router, PC1 learned all of its IPv6 settings dynamically. Which of the following answers list a protocol or message that PC1 could have used to learn all that stuff? And that's the NDP router solicitation, right? I send this out and then I get all the information from my router. And install the default route. PC1 dynamically learns its IPv6 settings using the Slack process. Which one of PC settings is most likely to be learned from the DHCP-v6 server? So, as a reminder, right, once I learn my prefix from the router, I can build my own address. And if I built my own address, the only thing that I'm missing to be fully functional on the network is DNS. And so that would be the reason for having DHCP. PC1 dynamically learns its IPv6 settings using Slack. Think about the host at unicast address as 2 parts, the subnet and the interface. Which answers list a way that Slack learns or builds the value of the interface ID? So you got your prefix from the router. How do you figure out what your address is actually going to be? And there's 2 ways that we can do that. We can build a random value, which is what a lot of hosts do, or we can do the EUI64. An IPv6 host is configured to use DHCP to lease its IPv6 address. The DHCP server is not on the same link. What address do you use for all of that? And we now know that instead of using broadcast like IPv4, you've got this all agents address that we use. So that multicast agent or multicast address that's specific to the DHCP servers. Question number 8, all routers in the network have global unicast addresses configured on their interfaces. The user of PC1 on a LAN issues a traceroute command for distant host's address. The command succeeds, listing 4 lines with IPv6 address, right? So if we know that remember how a traceroute works, which answer best describes the addresses in the traceroute output? Would you use link locals or global unicast? Well, it doesn't really make sense to use link locals because those are on this link. So you would never learn anybody else's link local address. And so the answer would be that it would be global unicast addresses. All right, friends and neighbors, welcome back. We are doing chapter 29 in the CCNA, volume 1, implementing IPv6 routing. Now, we've done some examples previously, but we're going to focus on a couple of areas on the routing table and all the different kinds of static routes in this particular video. This is also a little exciting because it is the end of volume 1. So next up, we got volume 2, some of the other areas we're moving up the protocol stack. All right, do you know this already? Questions? Router 6 in the figure has been configured with the IPv6 address you see there. The router also creates a link local address. All router interfaces are up. Which of the two following routes will the router 6 add to its routing table? Well, we know now that link locals are not in the routing table, so it'll add a globally unique address for itself and one for the prefix. Question number 2, a router has been configured with that address on one interface and another address on its G001 interface. Both interfaces are up. Which of the following routes would you expect to see in the output of the show IPv6 route connected command? And that would be the two prefixes. Question number 3, an engineer needs to add a static IPv6 route for the prefix 200123. Which of the following IPv6 route commands would result in a working route for that prefix? Well, you can say, I want to get to this prefix plus an interface or just the prefix without the interface argument. And the reason for that is that because we're using globally unique addressing for the next hop. The minute we use link local or a serial interface, we're talking about interfaces. Question number 4, an engineer needs to add a static route for 200123 to the router 5. Which of the following answers shows a valid static IPv6 route for that subnet? This is the one that I like, right? This is an example of a route that would actually work. 200123/64 via 2001-256::6, right? Forwarding hop here is a globally unique address. Question number 5, when displaying an IPv6 static default route, how does the show IPv6 route command represent the concept of a default destination? Well, we just saw this both on the slide and in the demo, : /0. Question number 6, router 1 has a useful IPv6 configuration so that router 1 learns a route for the subnet. The route lists an outgoing interface that is an Ethernet WAN link. An engineer then installs a cellular interface on both routers for WAN backup. Hint, hint, wink, wink, right there. It's a backup, so we don't want to use it all the time. So we're talking about floating static routes here. As part of the configuration, we add this part right here, which is the admin distance. What does the router do in the response? It accepts the route, but it doesn't add it to the routing table because there's one with a better admin distance there. And our last question, an engineer types the command IPv6 route to a prefix via 99::9 with an admin distance of 129 in the configuration mode of router 1 and presses enter. If we assume that there's nothing else going on, that means that we're not in an admin distance problem anymore. That means that this forwarding destination can't be reached to the router, meaning that this router is not connected to that particular network, and so there was no route to the next hop, so it doesn't appear in the routing table. All right, this has been Volume 1, Chapters 21 to 29 review. Don't forget those practice exams, right? Especially if you have the book, right? Make use of all that stuff. Lots of review material out there. Like and subscribe if this helps you on your journey, and we are on to Volume 2. May those packets always reach their destinations, especially the ones that are on their way to Volume 2. And hey, this is CCNA. We're halfway through our studying. You can do this.